Welcome to the R video tutorial on artificial neural network models in R. We've been talking about these in the last couple videos. We've talked about that there's a neural net package, there's the RS and NS package, which we didn't really do anything with. The ANN2 package we used in previous videos, but we want to get into something that's a little more modern, sort of cutting edge, and at the time of this video, it is cutting edge, which is the TensorFlow approach using Keras. And TensorFlow is Google's deep learning platform, and I want to make sure that you have the most up-to-date tools. So if you go on your job or you work at a job, you have access to the latest tools as of March 2020. All right, so this is going to take a little bit of time to do, so if you're watching this video, be prepared to pause along the way. We're going to use the pyma.csv dataset again. The reason we're going to do that is because you're familiar with it, and it's easy to get, so you can just jump onto the repository and get it if you don't already have it downloaded, which you already might have it. All right, so we're going to read it in just like we've done it before. You're going to need to set a working directory, but this will pull this in. This is what it looks like, and variable 9 is what we're interested in, which is whether or not they have diabetes. All right, so here's where it takes some time. You're going to go and install packages, quotes, Keras, and that will load really quick onto your machine. No big deal. Then you're going to go to the internet, and you're going to type into Google Anaconda version of Python, and it will take you to, I think it's anaconda.org. From there, you're going to install Python 3. This will take a while. Get some coffee, do something else. If you're watching this video, you might as well just pause it for a little bit until it's completely installed. All right, so once you've installed Python 3, now it'll have version 2.7 and 3 point something or other. You want the 3 point something or other. Now that it's installed, you'll go back to R. You will do this function here, install underscore Keras, open parenthesis, close parenthesis. Then you'll wait a long time as it installs as well. It updates the links between Python and R, installs TensorFlow, makes sure everything's set up so that everything works from R. Now, in this implementation, R is calling Python. So, are you coding in Python? No. But is it using Python? Yes. So just keep that in mind. All right, once you've waited a long time, now you can actually do something. All right, so first thing we're going to do is with our Pyma data set, well, we're going to load the library Keras. So we're going to have code library Keras. That'll load those functions for us. And then whenever we're doing things with neural networks, we often have to normalize the data. And this really helps the ANN converge faster. So what this little function here does is it just bounds the data between 0 and 1. So it takes whatever value we are, subtracts off the minimum, and then divides by the range of them. Okay, so this allows us to scale our data so it's all on the same scale and it's between 0 and 1, makes convergence of these things much, much easier. All right, now we're going to go take our data and we're going to transform it. All of them except for the last one. Remember, the last ones are 0 and 1. We don't need to do this. If you did do this, it'll just mess everything up. So we're going to apply our function to all of the data columns. Yes, you could use an apply function or something like that. I thought it would just be pedantic and just write them all out so you can see exactly what I'm doing and not have to worry about an apply function. All right, now that we've done this, we can partition our data. All right, so I'm going to cut this data in half. In the previous videos, I think I just chopped it off at like 500 and said, well, the 268 other values will be our validation set. But here I'm actually going to chop it in half. And so what I'm going to do is train size is going to be the number of rows of Pyma2 divided by 2. Now, if your data set isn't an even number of rows, you will have to round this one way or the other. I'm not going to do that here. All right, so our train index will be from 1 to 768, which is the number of rows in Pyma2. And then I'm going to pull out train size, replace equals false. I'm going to get these, and I'm going to pull them just like before. Pyma train 1 is Pyma2 train index, and this one should be minus train index. For some reason, the little minus sign's not on there, so put a minus sign in front of train index. All right, so then what we're going to do is Pyma train 1. We have to make this as a matrix. If you don't make this as a matrix, Keras is going to scream at you. You're going to be really upset. Bad times ahead. Okay. And then we're going to pull the last column as our matrix as well as what we're going to train on. We're going to do this with validation. But make sure your data is in matrix format. Otherwise, Keras will just give you all sorts of weird errors, none of which says turn it into a matrix. All right. So now this is where Keras really begins to shine because it allows you to build your model. The other one you just said, okay, I want these layers and how many in each layer. Here you're actually going to specify each and every layer. So the first thing you're going to do, I called this model 1, is you're going to say Keras model sequential, open parenthesis, close parenthesis. Basically creates a blank slate model. Nothing's in it yet. Then we're going to use model, and then we're going to use this dplyr sort of notation here. And it's called a pipe for some reason. But anyway, it's going to say, using this model 1, make a layer that's dense. The input shape has to match your data. Okay, we have 8 columns in our data. Input shape is 8. If you had pictures, you might have something that squares. So you would put in the shape of whatever that is. Here you're going to initialize the values in this so that it can start processing things for the kernel. And here I've got 8 units, which means this is the number of neurons I have in this layer. And here I'm using the activation function, a reticulated linear unit. Okay, this allows me to specify in each layer different units, activation functions. So I can do that if I want to. Here I've got another layer, dense, has 100 nodes in it, or neurons in it. Activation inside of that thing, sigmoid. Layer dense, units 1. This is my output layer, okay? Because I only have one output, I'm going to have units equals 1, activation equals sigmoid. We want sigmoid because the answer will be between 0 and 1. Okay? So just keep that in mind. Then you can get a model summary here. So if you do summary model 1, it said sequential underscore 33 for me because it took me 33 attempts to get this to work. Hopefully yours is a lot lower than that. All right, so what it does tell me is my first layer is dense, and its shape is none and 8. Dense, none, and 100. So these layers don't have to be layers like you're thinking of them being layers. They can be an array of nodes, not just straight, just linear layers. Okay, then dense 99 is none and 1. And notice the parameters. We have 72 parameters here, 900 parameters here, and 101 parameters here, for a total of 1,073 parameters. That's a lot of parameters. So just keep that in mind when you're fitting these things. A simple like logistic regression would only have like 9 parameters here versus over 1,000. All right, so now we got to go to the next step, which is compile the model. So we're going to compile it. Our optimizer is Atom. We're going to use binary cross entropy because we have a binary response, and the metrics is list accuracy. Still not fit the model yet. This is just telling it put the model together. Now, this is where we actually fit the model. So here I'm going to say model, pipe, fit, put in my X data, my Y data. Here I did 1,000 epochs. And this is how many times it restarts itself to try to get at a better model. And I did a batch size of 128, so it's going to do them in batches of 128. I wanted it to train this thing a lot because I want to see if I can do better than I did with ANN2. All right, so you're going to get a plot that looks like this going across, and this actually happens live. Okay, so you'll be watching this as you're training this model, and it will be happening live, and you'll see this thing improve. It'll take it a little while. This is one of those things where you want to get on your phone, text somebody, check Facebook, do something, anything, because it's going to take a little while for this to finish. And when I finished this, I had an accuracy, which you can see down here, is about 78.1%. All right, now that we've done that, we can go and get the predictive performance. We can predict it, model 1. Here's my validation data set. And this just gives me, in this case, probabilities. Okay, so I need to make pymapred2, which is if-else. If that probability is greater than 1/2, then give it a 1, otherwise a 0. And if I make a table of my predicted versus my actual, you can see I did pretty well. I only have 32 misclassified one way and 46 misclassified another way. Not too bad. I can also get my accuracy rate, which is 79.6%. The big question is could we do better? And that's what we're going to try to do in our next video, is start playing with this and get good at using Keras, because it gives us so much flexibility. We can fit all kinds of crazy models. All right, see you in the next video.